So for today, we are going to talk about the coordinate plane. And we're going to start talking about functions. A coordinate plane is a plane, oops, that's not how you spell this word, separated into 4 equal pieces. And it is used to graph. I am going to highlight my axes because they're a little difficult to see. And things we remember. We know this is X and this is Y. X goes left to right, Y goes up and down. We should remember our quadrant. So we know this is 1, 2, 3, and 4. And the other thing we can remember is our negative and positive part. So we know X and Y will both be positive here. X is negative, but Y is positive. Both X and Y are negative. X is positive and Y is negative. Ordered pair is basically just the X comma Y, and it's a point on a graph. Identifying our ordered pairs. First thing, we're going to identify the quadrant, and then we're going to identify the ordered pair, so our X comma Y. And we're only going to do a few of these. We are going to do.
I'm going to go into an action mode room to meet a student. I'm going into an action mode room to meet a student. Thank you.
We're going to do A, C, and F. So when I look at A, again, I'm going to highlight my axes. So I look at A and it's 1, 2, 3 over. So it's going to be -3. And how many up? It goes 1, 2, 3, 4 up. So it's the ordered pair -3, comma 4, and it is in quadrant 2. And we're going to identify C. C goes up 1, 2. And it does not go left or right. Now C is on an axis point. So for C, our answer is going to be the y-axis, because that's where it is. In F, we can assume the same thing. Since it is on the x-axis, we will put x-axis. And F goes over 1, 2, 3, 4, 5. So that's going to be -5, comma 0. And I'm just realizing on C, I put it backwards. So that's 0, comma 2. We could do all of these, but this is something that we assume we already know how to do. Coming down to graphs. There are 2 different types of graphs when we are talking about lines. We have discrete graphs, and then we have continuous graphs. Discrete graphs are graphs of random points. Continuous graphs are lines and curves. And as I said, discrete graph is a graph of points. So our discrete graph would look something like boop, 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 boop. And our curves, it could be this or it could be this. Now we're coming up to ordered pairs. Ordered pairs, when we are looking at our domain and range, our domain we know is X and our range we know is Y. And I'm going to go ahead and use the highlighter and highlight all of my x's. We have -3, -2, 1, 3, and the -3 repeats, so I don't technically need to write that one again. My range are the ones I didn't highlight, my y's. And we should write these in order from smallest to largest, so first is -4, then 0, 1, 2, 5. If I want to write those ordered pairs in a table, we do the same thing. So we would go -3, -2, 1, 3, and this time we do need to repeat our numbers. And our y values match up, so we'll have 1, 0, 2, -4, and 5. When we are mapping, we're going to take what we wrote for domain and range. So we're not writing the repeating values. And now I want to connect them. So I'm going to draw a line from 3 to 1. I'm going to draw a line from -2 to 0, from 1 to 2, 3, -4, and -3 down to 5. And again, we can review some of the graphing. We know we go over for x and up for y, so I need to go to -1, -2, -3, up to 1. -2, 0, over 1, up 2. And we can graph the rest of those points. As we just talked about, domain is going to be my x and range is my y. And we know x values go left to right. In range, our y goes up and down. So identifying the domain and range. How far left and how far right does my graph go? My graph goes all the way left and all the way right. So what we're going to say is x can be all real numbers. So we're going to write a C with a line through it. It's a fancy E, and then a fancy R, the abbreviation for for real numbers. So X ER means X is all real numbers. My range is how far up and down I go. Does my graph ever stop going up? It doesn't. It goes up forever, but it does make a turn and start going down, which is at -2. All of my y values are bigger than -2 because they're above it. So my y needs to be larger than -2. Looking at number 2, we have a lot of stopping points, a lot of turning points because it's a circle. My graph, or I'm sorry, my domain is going to look like this, and I'm going to have numbers. And my range will be really similar. And since they touch the lines, we can put equal to. My graph goes left 1, 2, 3. The farthest point is -3, and the farthest point right is 1, 2, 3. And same thing down. The farthest point down is going to be -3, and the farthest point up is 3. A function is a special type It's a special relationship between our x and our y, and it's special because our x values cannot repeat. Oops, there's no E on repeat. So an example of a function would be 1, 1, 3, 3. We could keep going on that one. And again, I only have one of every number in my x. So a counter example, 1, 1, 2, 2, 3, 3, and then we'll do 1, 3. And if I look at my x values, my 1 repeats. So that's why this is not a function. I'm going to highlight all of my x's because this asks, is it a function? I have 5, 3, 2, 0, and 1. None of those numbers repeat, so yes, it is a function. -2, 0, 2, 3, 2. I have 2 2's. So no, not a function. When looking at a chart, again, we look at our x values, we look all the way down, and we say, do any numbers repeat? Those repeat, so this is not a function. And nothing repeats here, so yes, a function. On 11, we're looking at the mapping version. What I want to do is look at all of my numbers and see, do any of them have 2 lines in the x? So again, we're looking at our x's. This has 1 line, so it checks out. 1 line, 1 line, 1 line, so yes. We don't care how many times, we don't care that y has 2. It doesn't matter, only the x. So looking here, I see -1 has 2 lines coming off of it, so it is not a function. So the vertical line test, we take a vertical line and we pass it through our graph. If a vertical line touches more than one part of the graph, at one location, then it is not a function. So we can come up with several different examples for a graph. I want this to be a one example would be a horizontal line. We could also do a vertical line. We could even do a parabola, a U. We could also do a U shape. If I were to come over here and draw a straight line, up and down, and drag that through my graph, I never touch more than one part of the graph. So let's do the opposite, and let's figure out some bad graphs. I can think of, there's 1, 2, at least 3. And one of them would be a vertical line, straight up and down. Another example would be like a circle. Oops. A circle. Or we could do a sideways parabola. And again, that's because if I pick my line up, I would touch all points of this line. Here, I touch 1, 2 parts of the circle at the same time. And same thing here, I touch 2 parts of my circle. That is why they are not functions. Running with that same rule, we're going to come down to some of these and identify them. But if I take my vertical line and go through, I notice right there, I touched 2 points at once. So this is not a function. Again, this one passes the test. So yes, it is a function. You can come down here and find another no. Easy, right there. 1, 2. Not a function. We've talked about domain and range for all of these. Domain and range from mapping. That is my domain. That is my range. Again, domain, range, and all of our x's are domain, all of our y's are range. We talked about graphing. One thing we did not talk about were equations. So if I'm looking at an equation and I want to find the domain and range, I need to actually guess and check. 2 numbers you should always, every time use would be the number 0 for x and 1 for x. If you want to use some other numbers, a good one to use would either be -1 or 2. We always need to use 3 numbers, but it's kind of up to you if you want to use -1 or 2. So now let's figure out what does y equal. So I'm going to take -1 and substitute it in. So now I have -1 squared minus 1. That gives me 1 minus 1, which equals 0. If I did 0 squared minus 1, I get 0 minus 1, which gives me -1. For the next one, I do 1 squared minus 1, which is 1 minus 1, which gives me 0 again. And I have 2 squared minus 1, which is 4 minus 1, which is 3. Now, I could have picked any number I wanted for x, which means x is all real numbers. My y values, however, there is a stopping point. I notice that I go 0, -1, 0. So right here, I get told to stop and turn around. And that's at -1. We turn around at -1. And all of my y numbers are bigger than that. And yes, it is a function. And that, ladies and gentlemen, is the end of this lesson.